A very pleasant evening to all the panelists and the participants connected with us. It is a pleasure to connect with you all. I welcome you all for today's webinar on the topic AI in electrical power systems. Dear participants, our expert for today's session is Mr. R.K. Singh, sir. Sir has already joined us and we will be beginning soon, dear participants. Dear participants, it is to inform you that the recorded video of this session shall be made available on our YouTube channel at the earliest possible by the end of this session. Also, the other important details would be shared on the chat window only. Further, it is to request you to kindly ensure that whatever device you're connected with for today's webinar, you are able to access the chat window, as chat window is an important mechanism through which we will be communicating all through the webinar. Any questions or any doubts you're having, you can write us on the chat window. I shall be facilitating those questions by asking them, but at the end of this session. Also, dear participants, we will be sharing a feedback form link by the end of this session. So make sure that you're connected with us till the last of this session and own yourself a certificate of participation despite increasing your knowledge. You may write your area of expertise and your name on the right hand side of the chat window. You can see it there on the right hand side of your screen. Good evening, Subramaniam sir. Welcome to the webinar.
Good evening, ma'am. How are you?
Good evening. Great, sir. How about you?
Okay, all right. Thanks.
Welcome, sir.
Yeah, Ayushi,
Yes, sir.
let's start, please.
Okay, sir. A very pleasant evening to all the distinguished panelists and participants. Bharati Vidyapeeth Institute of Computer Applications and Management BVI CAM in association with Computational Intelligence Society chapter of IEEE Delhi section, Computer Society chapter of IEEE Delhi section, Technology and Engineering Management Society chapter of IEEE Delhi section, System Man and Cybernetics Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity Group of IEEE Delhi section, Life Member Affinity Group of IEEE Delhi section, Inter-Society Relations Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology, Standing Committees of IEEE Delhi Section, Region 10 of IEEE, with the Associations Computer Society of India, Institute of Information Technology Professionals, IITP, ISTE Delhi Section, and IETE Delhi Center as technical collaborator, welcomes you all to the webinar on the topic AI in Electrical Power Systems. Friends, 8th January is the birth anniversary of Honorable Dr. Patang Rao Ji Kadam, founder Bharati Vidyapeeth Pune and founder Chancellor Bharati Vidyapeeth, deemed to be university. Pune and one of the tallest Congress leaders in the state of Maharashtra, having contributed immensely in educational, political, social, and cultural domains, especially for upliftment of the downtrodden societies, sections of the societies. February 13 is the birth anniversary of Honorable Dr. Vishwajit Kadam, Secretary Bharati Vidyapeeth Pune, Pro Vice Chancellor Bharati Vidyapeeth, deemed to be University Pune, and former Minister of State, Government of Maharashtra. With this background, and also in the backdrop of monumental occasion of Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence, with immense pride and honor, we are privileged to announce that we, with united hands, are observing 6th to 13th January 2023 as the birth anniversary celebrations week by organizing various thought-provoking lectures and activities both online and offline in pursuit of our guiding principle of social transformation with dynamic education. This technical lecture web series is dedicated to this auspicious celebration. Just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of an industry that I don't think AI will transform in the coming years. Very well quoted by Andrew Ng. The use of AI in the power sector is now reaching to emerging markets where it may have critical impact as clean, cheap, and reliable energy is essential to development. The challenges can be addressed over time by transferring knowledge of the power sector to organizations. AI can also improve the planning, operation, and control of power systems. Thus, AI technologies are closely tied to the ability to provide clean and cheap energy that is essential to development. This webinar aims to discuss various aspects of applications of AI in the electrical power systems. First, I would like to take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. Firstly, I would like to welcome Mr. Saurabh Agarwal, sir, Head of Strategy Growth, PSU Business TCS. I welcome you, sir, and I request you to please share your welcome address. Please, sir.
Thanks, Ayushi. Am I audible?
Yes, sir, you are.
Sorry, I can't switch on the camera. I'm on road.
No problem.
I'll continue this way. And thank you again. But let me start by congratulating Professor Hoda, his team, and BVI CAM for this series of webinars. Achievements like these require a high level of management commitment, a great deal of teamwork, a fine balancing of the choice of topics and speakers, and I think above all, continuous engagement with the attendees. We have seen during lockdown until even much later, when all of us were flooded by countless invitations of webinars, and towards the end, we had that online fatigue. No, we were not open to attending any more webinars. No, that was the level of fatigue. Even during those days, there was a lot of engagement in this series of webinars. With a large number of attendees in, I think, almost every session. And as I said, this is a great example of leadership, teamwork, resilience, and meticulous planning to achieve this feat. No, probably no. Many of us try to do it. Anyone can do it for a couple of weeks or for a few weeks or a couple of months, but to keep on doing it for over 2.5 years, we are coming near to 3 years. It is simply amazing. Uh, no, regarding today's topic, I think Ayushi, you made a good point. It is in AI has entered in every part of our lives, and with a great speed. Mm. No, for several decades, it was just a topic of academic interest. But now we are seeing so many use cases where AI can be implemented. Uh, it has made an impact in multiple areas, and not only in scientific and research, but also, as I said, in every aspect of our lives. And as our today's topic says, it's being used in power systems. Again, there are multiple use cases that we can think of. Problems like control, planning, scheduling, and forecasting. Uh, and AI is also helping in our sustainability initiatives, something that is the need of the hour in today's times. So I'm looking forward to hear from our learned speaker on specific use of AI in electrical power systems, and we are all will learn from his vast experience on this topic. So thank you so much, Ayushi, and over to you.
Thank you so much, sir. Thank you. I would now like to request Professor M.N. Huda, sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, BBI CAM, and Vice Chairperson, IEEE Delhi Section, to please address the participants with his inspiring words. Please, sir.
Am I audible?
Yes, you are, sir.
Good evening, one and all. In fact, today also I could not reach my home. I started from my office, thought let me reach home, but could not reach. So I've today parked my vehicle outside at the side of the road. Uh, at the outset, let me first wish you a very happy, healthy, prosperous, and safe New Year 2023. And then I would like to express my gratitude towards the valued speaker for today's session, Mr. R.K. Singh Saab, who by now has delivered a series of sessions at our platform, who always says yes to me as and when I request, and has got zeal of disseminating information, sharing knowledge with all of us. So thank you so much, Mr. Singh Saab. And I also take this opportunity to welcome my all the friends from various professional societies. I could see Professor Subramaniam Krishnamurthy right from the first lecture, June 2020. He keeps on attending almost all lectures. It is a matter of inspiration for many of us. And all my participants from various parts of the country and abroad. This is 108 lecture number of this series, which we started in June 2020 in the backdrop of COVID-19. All of us know that when COVID-19 somewhere in the March badly hit us, we had no clue what to do. Why only we? Nowhere in the world people have clue what to do, and almost everything was stopped. And then I read an article in one of the International Journal of Psychiatry that such pandemic has multiple stages, primarily the 5 stages. And one of the stage, which is number fourth stage, was very dangerous, depression. And the third stage was bargain, and the fifth stage was acceptance. So we decided at IEEE that if we pay attention towards engaging our fellow professionals into some learning activities, probably we may leapfrog from third stage, that is the bargain stage, directly to the fifth stage, that is the acceptance stage, without having faced the stage of the depression. And with that objective, this webinar series was started. This technical lecture series was started under the collaboration of IEEE, IET, CSI, IST, and all possibly all possible professional societies. Ayushi has already enlisted that. And since then, we are continuing it. This particular week, 6 to 13th, is also very special, very momentous, very auspicious for we people who are working with Bharati Vidyapeeth, that tomorrow, that is 8th of January, is the birth anniversary of our honorable founder, Dr. Patangrao Ji Kadam, who has been the founder of Bharati Vidyapeeth, established Bharati Vidyapeeth on 10th May 1964, and started from a small coaching institution, which by now has become a network of 187 institutions all across the country, including a deemed university having 33 constituent college of the deemed university. And one of the tallest leader of the Congress party has served to the government of Maharashtra close to 44 years. So tomorrow is his birth anniversary. And on 13th of January, before we meet again, there is a birth anniversary of our Honorable Secretary, Dr. Vishwajit Kadam, who is at this moment the member of the Legislative Assembly of the Maharashtra and the former minister in the government of Maharashtra, and one of the tallest youth leader of the Congress party across the country. He has served Maharashtra as the Youth Congress president as well. So this, from that point of view, this particular week, 6 to 13 January, is very auspicious for us. So this particular lecture series is dedicated to both the 75th glorious independent years of the India, that is Azadi Ka Amrit Mahotsav, as well as the 6 to 13th birth anniversary celebrations of the two stalwarts and the two founding pillars of Bharatiya Vidyapeeth. My dear friends, the topic AI in power electrical systems. In fact, as Ayushi has already introduced the subject and Mr. Saurav has already sensitized you that AI is entering into every walk of life. And probably gone are those days when the many grid stations, the power systems are going to be controlled manually or going to be controlled by switches. Gone are those days. Now the intelligent switching system in a big way is going to dominate the entire electrical installations, the entire power systems, and the entire mechanism, right from the providing and supplying electricity, supplying power, to in fact the managing and auto load balancing, and everything, all controls will be with the help of the intelligence systems. And that's how SCADA and many other intelligence systems are already in place. So artificial intelligence will probably enter into every walk of life, and not only the educated people, not only the well-to-do people, not only the people using advanced devices, but the people using simple gadgets, electronic gadgets, are also using in one or other way the artificial intelligence system. For that particular purpose, we have invited our expert, Mr. R.K. Singh Saab, to enlighten us that how AI is going to transform the entire power industry, and in which way the people and the consumers as well are going to be benefited, and how the seamless services can be made available to the people. That's the purpose of today's sessions. So I once again welcome you all, and thank you so much for keep waiting for this program. Last Saturday we took a break because of 31st of December, and next Saturday also we are taking a break. So after this we will be meeting on 21st of January, because 14th January is Makar Sankranti, and we thought that let's people to celebrate it. There are many other festivals in different parts of the country, different regions of the country. So after a gap of 1 week, on 21st of January, we will be again meeting, and again the next topic will be the robotics process automation. That how the automation is going to change our day-to-day life. And the webinar has already been notified for that. It is the 109th webinar. So those who have not registered, please register for that. And this webinar was started in the backdrop of COVID, and COVID has started again knocking our door. The almost 70% of the China is locked. So during the COVID time, I wrote that वक्त नाजुक है, संभल संभल के रहिए, वक्त नाजुक है, संभल संभल के रहिए, और जब तक न हो जरूरी घर के बाहर न निकलिए. इसमें थोड़ा सा अमेंडमेंट कर देता हूँ कि जब तक न हो बहुत जरूरी घर और ऑफिस के बाहर न निकलिए. तो वक्त नाजुक है, एंड विश यू अ सेफ, विश यू अ हेल्दी, विश यू अ 100% प्रॉस्पेरस ईयर 2023. और कोविड के सारे प्रोटोकॉल फॉलो कीजिए, ध्यान रखिए अपना, और बहुत ज्यादा ध्यान रखिए. Thank you so much. Wish you all the best. God bless you all. Over to you, Ayushi.
Thank you so much, sir, for always inspiring us. I would now like to welcome amongst us our expert speaker for today's session, Mr. R.K. Singh, sir, with an e-bouquet. We welcome you, sir. Mr. Singh, sir, has over 4 decades of experience in the field of broadcasting sector, inclusive of operations, general management, procurement, technology, and human resource development. He has extensive experience in complex and challenging international and multicultural environments, with proven ability to represent the organizations among stakeholders and strategic partners. An exemplary communicator with proven skills in designing and conducting customized training programs geared towards optimizing knowledge and operational efficiencies of employees. Sir also has expertise in conducting training programs and workshops in the areas of managerial effectiveness and broadcast technology. He has represented All India Radio in international seminars, conferences globally. Sir has also served to the government of Kenya, Nairobi for a period of 5 years. A renowned expert on the panel of DOE ACC Society for Inspection and Awarding Accreditation to Computer Training Center and bestowed with many eminent engineering awards and accolades. Sir is also the fellow member of professional bodies like IETE, IEBES India. We are honored to have you amongst us, sir. I would now like to request you to please enlighten the house. Please, sir. So please unmute yourself.
Am I audible now?
Yes, sir, you are.
Okay. Good evening to everybody. And I wish everybody
Sir, please unmute yourself. You are not audible.
okay. Now, is it okay?
Yes, perfect,
Okay.
sir.
So I wish everybody a happy new year. And I thank Professor Hoda for giving me the opportunity. And I once again, the only thing is what Madam has told about me, my qualification, I would like to just add one thing that basically I'm a graduate in electrical engineering. So that's why this topic. In fact, in engineering also, we learned the high voltage engineering and so many things. But when AI came, I thought that this is a important time. And of course, in my presentation, I will be sharing that. So now I will request to, can I share now, madam?
Yes, sir, please.
Yes, sir, you are. You can share, sir.
Okay, thank you. Yeah. So slide is visible?
Yes, sir.
Okay, thank you. So I will be using now here. I would like to mention one thing that in between, probably after this, my present first part, I will be using some videos. And Professor Hoda has allowed me. So with the help of Mr. Manish, I think he is there. I will be playing few videos which I feel are very important in connection with my presentation. But first, let us start with this. What is electrical power system? We all know. I mean, everybody is connected with the electrical power system, whether at small level in your house, as Hoda has already mentioned. It is coming from the grid and the industry. And of course, electricity is necessary for the functioning of modern advanced society. You just imagine when the electricity goes even for 5 minutes, we become so impatient, whether you are watching TV or whether you are doing any work, everything stops. So it is just a part of our life. Now, it is increasing as the, now the electricity has already reached in the villages also. Uh, Deals with generation, transmission, distribution, and utilization of electrical power and electrical devices, such systems like generator, motors, and transformer. But what is the main challenge? The main challenge is the fault prediction in the energy sector, along with real-time maintenance and identification of the ideal maintenance schedule. The energy sector worldwide faces growing challenges related to rising demand.
Excuse me, RK Singh sir, can I interrupt just for a second? Your slides are not visible. Only one homepage is there. If you have operated your presentation, sir.
No, yes, I have operated my presentation.
But the
It is not coming.
no, your desktop screen is there visible.
Mr. Manish,
I think you need to tap onto the presentation you want
Sir,
to
just
showcase.
double click on the presentation, sir. Hello.
is it visible?
No, sir, it is not.
No, sir.
Please double click on the presentation you want to
I think
open.
it got stuck.
My slide is visible.
Sir, please reshare the window, sir. Please, sir, end sharing.
Hello, madam.
Yes, sir, please
Manish?
say. Hello. Hello.
Hello, Manish.
Yes, sir. My voice is coming, sir. Hello.
Dear participants, we'll be back in few minutes. There is a technical glitch on the speaker's end. Kindly bear with it. Dear participants, we are resolving the technical glitch at the speaker's end. Please stay connected.
Manish, it will be better if you take PPT and share from our end.
Actually, sir, actually, internet was glitch, sir. That's why we are connecting the internet and we will be back soon, sir. Very soon.
अच्छा, कोई दिक्कत अगर पीपीटी में होती है तो उनसे पीपीटी ले लो, share
Okay,
it
sir.
from our end and then he can speak.
Sure, sir.
Dear participants, we are resolving the glitch at the end of the speaker. Till then, I would like to request you to please write your name and area of expertise at the chat window. It would help for better networking. Also, it would connect you with us and also ensure that you are able to check the and connect with the chat window. Thank you. Welcome, Daman sir. Welcome to the webinar.
Thank you very much. Good evening, everyone.
Dear participants, we are resolving the glitch at the end of the speaker and we'll be turning back soon. Please stay connected with us.
Hello? Hello?
Yes, sir, you are audible.
Yeah, I am audible, madam, on but on laptop it is not coming. My PPTs are on the laptop only. Why it is not coming on my laptop? I don't understand. Manish, वीडियो तो आ ही जाएगा खैर.
Sir, rejoin. Sir.
Manish,
Sir, please rejoin, sir.
eh?
Please rejoin from the laptop, sir. Please.
अच्छा, rejoin the laptop. Okay,
हाँ, rejoin from the laptop.
just a minute. अभी वही स्टार्टिंग वेबएक्स करके आ रहा है. अब आ जाएगा इस बार?
Yes, sir.
हैं?
आ जाना चाहिए.
हम्म. अरे इसमें पीपीटी मेरा जो चल रहा है, जो प्रेजेंटेशन है वो तो इसमें है ना, इसमें नहीं है. हाँ, तो पढ़ाना तो पीपीटी से है. अच्छा, खाली बोलना थोड़ी ना है. अच्छा, इसमें होगा वो ऑप्शन में, इसमें देना है. कैमरा सेटिंग नेट तो चल रहा है इनका. हेलो मनीष. मनीष,
Yes, sir. Hello.
हेलो मनीष.
Yes, sir.
हाँ, मैं वही स्टार्टिंग वेबएक्स करके घूम रहा है लैपटॉप पे यार.
सर एक काम करिए सर कि आप लिंक कॉपी करके आप ब्राउजर चेंज कर लीजिए दूसरे ब्राउजर पे.
लिंक, अच्छा कोई दूसरे ब्राउजर से करो. ओके,
Yes.
एक मिनट फिर.
जी सर, मैंने अपना ईमेल आईडी सेंड कर दिया है सर. आप पीपीटी मुझे उस पर सेंड कर दीजिए सर. जी जी. नहीं, ज्वाइन करने के लिए पूछ रहा होगा सर आपसे. जी जी आ गए सर, आप आ गए सर. Yes sir. I am making you the presenter sir. Now you can start the presentation sir. Yes sir.
Okay, okay, now. Right. So now I directly played my video first. Is it okay?
Yes sir. Your voice is coming sir. Sure.
Yeah, ठीक है. Okay, friends. Now I'm very sorry for the inconvenience. I hope you are getting my slide also, madam.
Yes sir.
Yes,
It is
sir.
visible sir.
Okay. So I will straightway go to the high voltage transmission line. And before we discuss further, we all know that transmission lines are charged up to 440 kV and above. I mean, there are lines of the 700 kV also. And now we are using robots for the inspection of these transmission line and eliminate the hazardous risk to the lives of the line inspector. Now, actually, as per the Forbes, inspection and repairing of the transmission line is the 7th most dangerous job in the world. Please note that the transmission line maintenance is the 7th most dangerous job. The professionals' use of a robot for this inspection would eliminate the risk by 100% and increase the data accuracy. The main purpose is to inspect the physical line conditions, overhead line, and I would request you to watch this video.
Sir, video is not coming. Please.
Wait. Yeah. You see, now it is coming, sir. Now it is coming. You are getting my voice?
Sir, video is not showing sir.
Video is not coming.
Not coming sir. Please share your entire screen sir. Please.
Hello, Manish. But video तो हमने test किया था ना?
Yes sir. But you are sharing only one window sir. That is PPT window. Please share entire screen so that the
Okay.
video will be visible.
Now which one I have to share?
Press escape key sir.
Escape key. Okay.
And yes sir.
Yeah.
Now go to that. Please unshare.
Pardon?
Please end sharing sir. Please.
And sharing.
Yes sir.
Okay. Now I am sharing.
Now please share the screen. It will show
Yeah.
the.
I share the screen one.
Yeah. Yes sir. Entire screen.
Okay.
Yes. Now show your video sir.
I play video. Is it visible?
Sir,
Yeah,
it is
just
coming,
a
sir.
minute. Is it coming?
Yes, sir. Video is coming, sir.
Okay. And my voice is also coming?
Yes, sir. Your voice is also
Okay.
coming, sir.
Now, friends, this is about the how transmission lines are monitored or checked. Just watch this video. This is very interesting. See, earlier person used to walk on the transmission line for checking the transmission.
So that's why we developed Explain. This machine, we don't need to stop the transmission of electricity. It can move like lights. Here in Japan, we're using.
They are using robot.
Up against obstacles while traversing the lines. It can manipulate its center of gravity to move around. There's a huge need for spacers. There are kind of spacers that are used to leave the distance between the lines. And those are still.
See, the robot is crossing itself. Those separator.
Basically a metallic. So this is one of the strong points of Explain. It's developed in order to be able to do some, we call them automatic actions on the lines to overcome the obstacles and continue expanding. So for example,
This is interesting.
to one side, we end up lifting using the other side. By lifting the pulleys, then we can do acrobatic moves I was talking about. Maybe outside, use them to overcome obstacles and so on. The robot uses 8 cameras to and simultaneously, continuously recording a 360-degree view of me. It also records music, as well as the distance from the tower, so that any defects are not only easy to work out, also so operators can track the deterioration of the lines over time. After inspection, the gunner is automatically processed on the ground. Any anomalies found, such as ruts, defects, surface damage, or line diameter changes, which can be indicative of volcanic corrosion, are flagged for inspection. As for future operations, we have a few based on this concept. Operations based on works on the lines. Not only inspection, but even maintenance structure. But this is still under consideration.
Okay. Am I audible? Okay.
Yes, sir.
I know many times seen this ad by saying, who is this guy teaching me how to run my own business? I agree with you. मैं अगर आपकी जगह होता तो शायद मुझे भी ऐसा ही लगता. But you listen to this. This workshop is conducted by business coach Dr. Amit Pai. What did he do?
Sir, now start the PPT, sir, please.
Hello.
Sir, start the PPT.
I am starting the PPT. Hello. No.
Yes,
I'm
sir.
sharing now. Is it coming?
Yes, sir. Kindly unmute. Kindly mute the laptop, sir, please. Laptop sounds. Laptop
Take
sound.
it. I mute the laptop.
Laptop sound mute. Echo is coming, sir. Actually.
Echo. No, but I have to
This is
share. No?
icon on. just beside the ENG, where the time and date is displaying.
Which
Yes,
one?
sir. Yes, sir. Yes, sir. The
Here?
sound one. No, just beside that. Left to that, right to that. After the ENG. After
After?
ENG.
Okay.
After that.
Then I have to click. Acha, this one.
No, sir.
Huh.
Left to the ENG.
Okay.
Yes, sir.
That is speaker.
And
Unmute.
mute
Okay.
it.
Okay, fine.
Okay, sir. Now echo will not come. Now share the
Right.
screen, sir. A screen is
So-
your sharing. Just open the PPT. Just open the PPT.
Yeah, I
Don't
will
share.
open the PPT. Now, where is my PPT? Presentation has to come now.
Yes, sir. In your folder, there will be a PPT.
Is it okay?
Yes, sir.
My PPT is visible
Yes, sir. Visible, sir.
and my voice is coming?
Yes, sir.
Okay. But should I try my video again?
Yes, if you want, sir.
Yeah, I won't actually. The next video is also very good. So now this drone, this video also. How drones are used for laying the line, transmission line.
Video is coming, sir.
Just a minute. Some ad comes, I have to remove that. Yeah, is it okay? Video is visible
Yes, sir. Visible, sir.
and sound?
Sound is not coming, but still it is okay, sir.
Okay, then anyway, let them see this. Okay, even it is written also. Now in this video, you will see that how the drone is used for laying the transmission line. And this is a very tedious job. But how the drone will take the wire, the cable, and how it will connect. Just watch this. Drone is taking the wire is connected. They are just sending the wire with the help of drone. And it is going, and then you just watch how it will connect to the tower. It will automatically go to the tower. It will open the socket, and then it will see. Now it is coming, and it is connecting to the tower. Yeah, now it will come and it will open the clamp. Just see this clamp. Yeah, it has opened. And now the wire is coming. It is coming to this line, and drone is pulling it. See, now drone is pulling, and the wire, it is taking the wire to the next, So this is how the transmission line is laid. You can see that. And I will show you another. Yeah, you can see that. See this another one. Now how the robot My audio is coming?
EPRI is developing a
Hello,
Yes, sir.
Mani?
Yes, sir. Yes, sir. Your audio is coming, sir.
that is designed
Now
to
how this robot
transmission
will be inspecting the line. You can see that robot is moving on the line. And the interesting part is that even if some tower comes, it will jump over the tower also. And it has connect, cameras are there. You can see the cameras are connected to the robot.
the end of 2010. Technology,
And they are testing it.
the test line was built that
And this is the trial they are doing on the feeder line.
scenarios.
See, now when the robot is going, even during the connection, see how smartly it is just passing.
Design of the electronics that provide and the sensor systems that will be integrated in. Concepts such as testing, test to validate. Just automated.
Okay, I will go to the next one.
The LiDAR sensor.
Hello,
Size and presence.
just a minute. Yeah, this is how the robot is doing the maintenance in the electrical substation. My voice is coming?
Yes, sir.
Hello,
Yes, sir.
Mani?
It is there.
Okay, so how this robot is doing the maintenance even in a dangerous place? See, we are there to refinery in the Netherlands, and he is explaining that how the robot will help us. And this robot is doing the things of its own. It is taking the decision. It is all with AI.
Collect random data. So where needle gauges and lubricant levels are today collected by people, the robot now fully autonomously takes the pictures of the gauges, reads them, and sends them to our data storage. So the end-to-end data flow is already fully automated. Now with Spot, we have a new machine that can do more. It offers us that mobility platform of legs, so we can go places where robots with tracks cannot go yet. The good thing for us at Shell is we're fully ready for that. The software part behind this, Energy Robotics, has already provided the cloud, fully integrated into Shell's cloud, so we're ready to run one of the highest power tower in this world. The power tower is standing right beside me. Also standing beside me, Mr. Bill Hart, engineer from the State Grid, Zhejiang Electronic Power Company. So good morning.
Transmission modified
So, well, here we are, right? What is this? What is this giant?
As we can see, this is our tallest electric tower. And this project is called Zhoushan 500
Happy spiritual morning.
network connection.
Welcome to the 5 days boot
And
camp.
every time I see
how-
this tower, I feel shocked.
Every time Boston Dynamics
I feel
puts out one of the big
shocked
YouTube
and-
productions,
and
the world
amazing.
is amazed. The robots
Because
dance
I
or they do
think
parkour,
it's much
all of
more
which
than a
is very
tower,
impressive,
but it's a
but it's
great
under controlled conditions in a lab. It's not exactly
with our
practical
wisdom
real-world use.
and hard work.
So what are those robots
Well,
actually being
well,
used
with
for in the real world?
Wisdom and hard work.
Inside
So
this
what
mountainside
is
in
it
Western Austria
for?
is a
So what is the
hydroelectric power plant.
objective
I
of
would have filmed this
building
piece
a
of camera
tower
actually
like
down in the
this?
turbine hall, but it's a bit loud in here. Over 150 tons of water a second goes down to the uphill reservoir, through the turbines in the cavern, generating 350 megawatts of power. And it's all run remotely. Switching this plant on and off down to the control center, about half an hour to make that way. But they also control 20 other hydro plants. On a normal day, no one works here at all, but for safety, someone does have to regularly drive out to all those 20 power plants and check that the physical things work as they should. So, let me see where this is going.
We are using robots to continuously do inspection tasks and therefore testing. This is possible in the middle of the house. Energy Robotics is putting software on robots to make them smart. We are a software company and we're not building the hardware. We are running code. Therefore, we ask other companies to build the hardware or use existing software. We work with a lot of robot companies to pick the best robot for the task.
Boston Dynamics and other companies build the actual physical robots and provide a remote control that allows you to directly move blocks around. But they also provide the interface to the computer. The robots have built-in navigation and supports. So, in the same way you can write code to automate things on a regular computer, you can write code for the robot dogs. Your code can learn the whole site you're working at and tell the bot, okay, find your way to this point, look at this thing, take a picture and a temperature reading, and if that picture doesn't look like it should, or there's something blocking your way, let us know about it.
Robot is not
Hello?
doing
Hello? Hello, madam. Am I audible?
Close the browser, sir.
Even my slide is visible?
Your slide is visible, sir, and please close the browser, sir.
Pardon?
Close the browser. YouTube is all.
No, my audio is coming now. Now I want to go with my PPTs only.
Okay, no issue, sir. The video is already running, sir, behind.
PPT is running now?
PPT is running, but video is already running behind, sir.
Okay, just a minute. How to stop? It is running now. That will stop.
Yes, but this isn't a particularly dangerous site. Let me in, after all. It's just inconvenient to drive here.
On some other browser, sir.
When snowstorms might close the mountain road entirely. This is a place designed for human approach, which is why robots with wheels and tracks are providing.
So it's important to have a robot which is capable to operate in human environment, because all the infrastructure humans have built has been built for humans. Therefore, we need a robot to be capable of interacting with this environment. Means simply, if we have a situation like here, we need to climb stairs, we're using a robot on legs. In the substation where we have flat ground, for example, we're using robots on wheels or on tracks. We're developing a skill which we use in oil and gas.
Sir, close other tabs, sir.
Is it okay now?
Yes, sir. Please close other tabs, sir.
Someone lying on the
Which
ground.
tab?
Other tabs, sir, which are not running.
Yeah, I'm doing that only. But
This trial will succeed or fail based on two
Close the
questions.
tabs,
First,
other
every
tabs
time
on the browser,
dynamics
sir.
is shown, is it cheaper overall than sending out people, particularly when the migration is.
I want to stop it.
Yes, sir.
Is it okay now?
No, sir. Sir, please share your screen, sir.
The resolution you get back to the Einstein will not be the substation is growing due to the change
You
to
told me
renewable
last
energy.
night
They
there
need to have enormous on the ground because we have not enough engineers to work for right now, and we need about 400,000 more productions to the world. The robot can perform up to 12
Sir, close the browser.
60 minutes charging, a lot of inspection.
Is it okay?
Yes, yes, sir. Now share your PPT, sir.
Okay. Okay, is it okay now?
Yes, sir. Please share the PPT.
But my voice in just a minute. It should come in the. Hello. Hello.
Yes, sir.
My voice is coming.
Yes, sir. Coming, sir.
No, in the laptop. It is not coming. Hello.
Yes, sir. Please unmute the video, sir, audio, sir.
एक मिनट वही कर रहा हूँ Is it okay? Now am I audible?
Yes, sir. Your voice is coming, sir. Your voice is coming, sir.
Hello?
Yes, sir. Your voice is coming.
No, but on the laptop it is not coming. Is it okay?
Yes, sir. It is okay, sir. No
So
issue,
I
sir.
continue with my PPT.
Yes, sir. You should continue, sir.
But then on the mobile,
On the mobile, you will get your audio, sir.
okay, on mobile I am getting my voice, right?
Yes, sir.
Okay.
Now mute your, sir, laptop.
I'm using only my laptop.
Yes, sir. Once again, mute the laptop, sir.
Okay. But why it is not coming on the laptop in my earphone?
Sir, because you have muted the sound, sir, laptop. On the laptop, you have muted the sound.
Okay. Acha. My voice is coming?
Yes, sir.
So I continue like this.
Sure, sir. Sure, sir. Sure.
Okay, fine. So now,
Open the PPT,
anyway,
sir, please.
I'm sorry that my videos were there. I don't know how far you have seen. But the whole thing is that now that technology is going very fast. And you have seen that how AI is taking interest, in maintaining the transmission line, and robots are being used, even going into dangerous places, and they are helping us. So, but the main thing is fault prediction. That has been one of the major application AI in the energy sector, along with the time maintenance. In an industry where the equipment failure is common, with potentially significant consequences, AI combined with appropriate sensors can be useful to monitor equipment and detect the fault. The use of AI in the power sector is now reaching an emerging market where it has critical impact as clean and reliable energy. The challenges can be addressed over time by transferring knowledge of the power. When designed carefully,
Sir, have you shared
AI
your
systems
PPT,
can
sir?
be particularly useful in automation of routine and structured tasks.
Excuse me, sir. Have you?
Now, I have already shown you that the drones are being used for the maintenance. In fact, drones are taking the pictures and they are sending this information in the control room.
Sir, sorry
And
to
in
interrupt,
fact,
but again, your slides are not there.
Slides are not there.
No, sir.
Okay. I don't know why earlier. Just a bit. My slide is visible, madam?
No, sir. Your screen is visible, but we cannot see your slides and presentation.
Okay.
Sir, please minimize this window. Please minimize this window, sir.
Is it? Okay, now let me share again then.
Sure, sir.
Is it coming now? Hello? My slide is visible?
Yes, sir.
Okay. Is it visible?
Yes, sir.
Hello?
Yes, sir, it
Huh?
is.
Okay. So for maintenance, drones are used, and they are getting the information and sending it to the control room. Now, energy efficiency decision making. See what happens, the smart devices such as Amazon, Alexa, Google Home, and Google Nest enable customers to interact with their thermostats and other control system to monitor their energy consumption. It depends how much energy you are using it. The digital transformation of home energy management and consumer appliances will allow automatic meters to use AI to optimize energy consumption. With population growth and urbanization in emerging markets and resulting expanding cities, AI will play a pivotal role in the efforts by using data, including grid data, etc. Furthermore, in deregulated markets such as United States, where consumers can choose, see what happens in many countries, you have got different power supplier. I mean, you can choose the power supplier. Then the AI will decide which one will be the best for you. And this one is now, as it happens in our country also, the theft of the power, prevention of losses due to informal connection. हमारे यहाँ भी लोग जिसे हम कहते हैं ना कटिया मार के, when they will put the wire on the transmission line and they will take the power without paying anything for it. So this type of loss is there, that is prevention of losses due to informal connection. It can also optimize costly and time consuming, but AI can stop this thing. The University of Luxembourg has developed an algorithm that analyzes information from electricity meter to detect algorithm. Now what I will do, friends, I will mention few AI systems which are used in the power system. AI which is used in the power system, and there are four. Normally they are used: expert system, fuzzy logic, and artificial neural network and machine learning. So I will just take the first one. Now, expert system, that is one of the oldest. In fact, when I was working in All India Radio Lucknow, then in my high power transmitter, for the fault diagnosis, I had also developed an expert system. It is a rule-based system, and on this algorithm is written. So if there is any fault, it will work. And this, in fact, I got the international award also for my system. The same is used in the electrical power system also, because more or less the broadcast transmitter and power system, there are many things common. So it is a knowledge based, and the rules are written. That if some of you must be knowing, if and then, if this is this, then this will happen. So expert system is a knowledge based system, and with that we write the rules and we use it for the power system. Can we modify the expert system for new situation or other than already programmed? No. Normally, yes, it is possible. When new thing comes, you can write the new rules. So expert system, why many applications in power systems, including design and analysis, met with the ability of the expert system. Expert systems are especially useful for problems where a large number of data and information to be processed in a short time. So this is how my transmitter also was working, and we could diagnose the faults. In a similar way, a power system also, many fault diagnoses can be solved with the help of expert system. But this is the few things which I will skip because of time constraint, how it works, this expert system. So, and this is the basically block diagram of the expert system. Okay, the second one is, you must have heard about it. What is fuzzy logic? Now, fuzzy logic, in a simple way, we can explain, it can be visualized. Hello, you are getting my voice, no? Hello? Hello,
Yes,
you
sir.
are
Your
getting
voice
my
is coming,
voice?
sir. Voice is coming, sir.
Okay, fine.
Audible.
Okay. So fuzzy logic can be visualized
You are audible.
as a many valued logic as compared to Boolean logic. Now, actually what happens in Boolean, the output is either 0 or 1. We know that. But it is not always necessary that we should get the either 0 or 1. There may be many things in between. Fuzzy logic gives the output in the form of truth values. That may be any real number between 0 and 1. And fuzzy logic stems from the mathematical study of multi-valued logic, whereas ordinary logic deals with the statement of absolute truth, such as, is this object green? Now, this is just a question. Fuzzy logic addresses the set with subjective or relative definition, such as tall, large, beautiful. So like that, if they are called fuzzy logic. This attempts to mimic the way humans also analyze the problems. Now, for example, in the power system, if you find some some current or voltage, high or low, then you can say it is very high or low. So those, we use those values and try to find out the fault. That is fuzzy logic. There may be some cases where the output can be completely true or completely false. Sometimes it may be that either voltage is there or voltage is not there, but then many times it is not correct. In some cases, it may be say that voltage is not 0, but it is less or it is more. So these type of things given in the fuzzy logic. Fuzzy logic finds its application in the control of power systems like voltage control, stability control, power flow control, stability analysis and enhancement, load forecasting and performance improvement of transmission line. So when the values are not absolute values, they come under the fuzzy logic system. And fuzzy logic system is very simple. Modern power system is a complex network and requires high-speed, precise, and reliable protective system. Faults in power systems are unavoidable, and overhead transmission line faults are generally higher compared to other major components. The fuzzy logic-based fault identification and classification is easy and simple. Why fuzzy logic methodology is useful in all systems? Fuzzy logic is a non-linear problem-solving control system methodology that lends itself to implementation in system ranging from simple, small, embedded. It can be implemented in hardware, software, or a combination of both. Fuzzy logic provides a simple way to arrive at definite conclusion based upon vague, ambiguous, impressive, noisy, or missing. Fuzzy logic is different from conventional control method as it incorporates a simple rule-based, if X and Y, then Z. That is the approach to solving a control problem. So this is just a block diagram. So from the transmission line, we take the reference and then we compare it to the rule-based, and then the output is given. Well, I will skip few. How linguistic variables are used in fuzzy logic. Terms and definition. The linguistic description provided by the expert can generally be broken into several parts. There will be linguistic variables that describe each of the time-varying controller inputs and outputs. Linguistic variables assume linguistic values. That is, they can be described by the following. Now in fuzzy logic, please note this. say negative, high, negative, low, 0, positive, low, positive, high. So these are the terms they are used in fuzzy logic, because in general also we don't get absolute value, but we get these approximate values. Note that we are using negative low as an abbreviation for negative small in size and so on for other values. Such abbreviations keep the linguistic description short yet precise. The linguistic variables and values provide a language for the experts to express his or her ideas about the control decision-making process in the context of the framework. So this was about the fuzzy logic. Now I come to the artificial. Am I audible, madam? Hello, Manish?
Sir. Yes, sir.
Okay, fine. So now I come to the artificial neural network. Many of you must have heard about it, and this is one of the very, very important system in AI. Now, artificial neural networks are biologically inspired systems. It is very interesting to learn this. Artificial neural network, mathematical models simulate the human biological neurals, how our brain works. They have copied that system into this. Each type of neural network is capable of some specific work after being trained and is able to conclude a function from observations faced in real life, such as function approximation, classification, data processing, etc. Now here, this picture is very interesting. The first one, the top one, this is how our human brain works. See, we have got many cells, you know. So this is the dendrites. They are all input. These are all input. And this is the cell body. This is the nucleus. Now what happens? So many things comes to our brain, if each, and then the cell body process it. And then through axon, it goes to the next cell. So this is how the information is transmitted in the neural network of the human. And this has been copied in AI. What happens? We take many inputs and then we process it and send the output. So if you ask me what is the difference between a biological and an artificial neural network, our brain contains about 86 billion neurons. Our brain contains 86 billion neurons and more than 100 trillion synapses, that is connections. Synapses means those connections, you know, if you see that. See, these are the connections. The number of neurons in artificial network is much less than that. As compared to our brain, the actual neural network, when they say it is about 10,000 or so, comparing with their number. Perceptions just take the input on their dendrites. The whole idea, whatever input is given, it is given to the dendrites and generate output on their axon branches. If you see this is the axon branches. It takes input and then give it to the axon branches. Similarly here, it takes lot of input and then is given to the output. A single layer perception network consists of several perceptions that are not interconnected. They all just perform this very task at once. Deep neural networks usually consist of input neurons, the number of features in the data, output neuron as many problem. I'm not going into the details of the artificial neural network because this itself is a big topic. It requires a separate lecture. All the layers are usually fully connected to the next layer, meaning that the artificial neurons usually have as many connections as there are artificial neurons. Convolutional neural networks also use different techniques to extract features from the data that are more sophisticated than what a few interconnected neurons can do alone. Manual feature extraction, that is altering data in a way it can be fed to the machine learning algorithms, require human brain power, which is also not taken into account when summing up the number of neurons required for deep learning. In fact, this artificial neural network is very, very critical, very important as far as deep learning is concerned, because in machine learning, there are limitations. When there are many things, inputs are large, the machine learning sometimes does not work. Then we go to the deep learning where artificial neural network comes into picture. The limitation in size isn't just computational. Simply increasing the number of layers and artificial neurons does not yield better results in machine learning. That's why machine learning will not yield the result. So we have to use artificial neural network. Its primary advantage is the capability to learn algorithms and online adaptation of the dynamic system, quick parallel computation, and intelligent interpolation of data. They are classified by their architecture and a number of layers, topology, connected patterns, feed forward. Now, artificial neural network, though it takes the similarity of the human brain, but now I will try to explain. It's a simple construction. Now it has got consist of some layers. First is input layer. The input layer unit do not process the data and information, but distribute to other units. So input layer only take the data. It will take the data, it will not process the data, but it will distribute to the other units. Hidden layers. The hidden units provide the ability to map or classify the non-linear problems. And then our output layer. The output unit encodes possible values to be allocated to the case under consideration. Now see, this is just like you will understand. There are many layers. The first one is called input layer. You can see this one. And here all the inputs are given. Even in power systems, all the values, voltage, current, etc., whatever there, it is given. And then it is given to the middle layer. And they are processed, and then it comes to the output layer. Artificial neural networks are fast and robust and do not need any appropriate knowledge of the system model. Since they are fault tolerant, they can handle situations of incomplete or corrupt data and information. ANN is based on biological neurons. This I have already explained, so I will just skip that. Emulate behavior, yes. System for load forecasting and modeling. I think I'm repeating. How fault is detected in the power system? The electrical power system consists of so many different complex dynamic and interacting elements. Naturally, in electrical power system, there are so many inputs which are always prone to disturbance or an electrical fault. See, when the power system is working, there are a lot of data and they get disturbed moment some fault comes. And the use of high capacity electrical generating power plants and concept of grid, synchronized electrical power plants and geographical displaced grids required fault detection and operation of protection equipment in minimum possible time. The faults on electrical power system transmission lines are supposed to be first detected and then be classified correctly and should be cleared in least fast possible time. Because in power system, we know if fault has come, it should be cleared in the minimum possible time to avoid big damage. The protection system used for a transmission line can also be used to initiate the other relays to protect the power system outage. A good fault detection system provides an effective, reliable, fast, and secure way of relaying operations. The application of a pattern recognition technique could be useful in discriminating the faulty and healthy, healthy electrical power system. It also enables use to differentiate among three phases, which of the three phases is experiencing fault. Number of transmission line configurations are possible, as there can be any possibility from short length, long length, single circuit transmission line to double circuit transmission line. The conditions of electrical power system change after each and every disturbance. Yes, we all know that in suppose some fault has come and it was not a permanent fault. Some tree branch has fallen on the transmission line, but immediately it will burn, it will go. So that means the fault came for a very short time and then it cleared. Hence, a neural network is capable to incorporate the dynamic change in the power system. That is called dynamic change. So the fault came and it vanished. So neural network is capable. The artificial neural network output is very fast, reliable, and accurate, depending on the training, because its working depends upon a series of very simple operations. The algorithm which employed ANN programming offers many advantages, but is also suffers with many disadvantages, which are very complex in nature. Some of the important factors are selection of type of network, architecture of network, etc. How fault is detected in power system? There are various parameters like values of the pre-fault and post-fault voltages and current of the respective three phases in steady state required for precise detection and classification. What was the values were there before fault and what are the values after the fault? The values of the pre-fault and post-fault voltages and current of respective three phases are very different and are governed by the type of fault. Thus, the fault classification methods required a neural network that allows it to determine the type of fault from the patterns of pre-fault and post-fault voltages and currents, which are generated from the values measured from a three-phase transmission line of an electrical system. The neural network is based upon the 6 numbers of input, that is the voltages and currents of respective three phases. The neural network is trained by using these 6 inputs. In the back propagation neural network, this of course I will not go. It just says that in the back propagation, what happens. The error for each iteration, this also I can skip. Okay, now what happens? The weightages are provided in the neural network. And then we say that what is more important, what is less important. After each step, the weights are updated with the new ones and the process is repeated for entire set of inputs. This process is repeated until the network converges for the given values of the target. The back error propagation, again, this is about the back error. You can see how it works, but I will not go into the detail. Okay. Now I come to machine learning. As you all know, that machine learning includes a broad range of algorithms. There are many types of algorithms and statistical models that make it possible for system to find patterns. Because in machine learning, earlier I have explained in my earlier talks that how it works. So machine learning has got so many advantages: supervised learning, unsupervised learning, and reinforcement learnings. Now, deep learning also, I have just now told you during ANN that deep learning is a form of machine learning based on artificial neural network. Deep learning architectures are able to process hierarchies of increasing abstract features, making them especially useful for purposes like speech and image recognition. Machine learning applications in electrical engineering. Machine learning is a great concept in which machine will have the ability to learn things without being explicitly programmed. The interesting part is that there is no programming as such. So machine learning will learn from the data itself. Have you ever thought that machine learning can be used in electrical field? Well, here I will share some domain or field of electrical engineering where you can apply machine learning concepts. Let us discuss one by one. But please remember, in machine learning, there is no programming. The machine learns from its own data, whatever data is given. Number one, speed control of motor using machine learning. Hereby, using some data sets, you can train a model to control the speed of the motor in both forward and reverse rotation with regenerative braking. Second, smart grid using machine learning. Smart grid means everything will be handled automatically whenever fault occurs. If there is any fault, it will be taken care by machine learning. You can apply machine learning in smart grid to make operations easier. Third, battery management using machine learning. The battery management system is a device that will monitor and control the battery state of charge, voltage, temperature, etc. Fault detections using machine learning. The fault in the transmission lines and distribution lines are very common. Here, machine learning algorithms can help to find the spot where the fault has occurred. It can give you the location of the fault. Solar power plant using machine learning. Here, the machine learning concept will help to generate maximum energy. Means by using machine learning method, you can design a system which rotates the solar panel at 360 degrees. Control system using machine learning. Control systems are commonly used in industries. Here, the machine learning can help industries to control devices very efficiently without any fault or damage the system. So, yeah. Now I come to my last, point. I will not take much time. I hope I can take few minutes, madam. Hello.
Yes, sir,
Manish?
please, sir. Please, sir.
Yeah, okay, thank you. So now let us see the future of the power sector. Well, so far what we have discussed, while AI holds considerable potential to improve power generation, transmission, distribution, and consumption, the energy sector in both emerging market and advanced economies continue to face multiple challenges in terms of efficiency, transparency, affordability, and the integration of the renewable energy source in power. So these are the challenges we have to face. First, AI companies have expertise in math and computer science, but they often lack the knowledge needed to understand these. I am telling you the challenges in the power system when you are using AI. So AI have expertise in math and computer science, but they often lack the knowledge needed to understand the specifics of power system. And this problem is more acute in emerging markets, while the potential applications of AI in the power sector are multiple and varied. There is a need to educate the AI industry. That means there has to be an understanding with the AI industry, those who are developing the AI with the power sector. While AI holds considerable potential to improve power generation, transmission, distribution, and consumption, the energy sector in both emerging markets and advanced economies continue to face multiple challenges in terms of efficiency. So that we have to face. For example, cloud-based applications are widespread and central to AI solutions, but there are regulatory restrictions. Say in many countries, there are many AI solutions are available in the cloud, and cloud is accessible to everybody. So there are regulatory restrictions. So if you are using AI like that, probably it may not be allowed. This is changing, however, as the benefits of AI cloud applications becomes more evident. Second, the reliance on the cellular technology limits AI's potential in rural. Now, this we also know that the continuity, the data is important, but in rural areas, the cellular technology is limited. So that creates a problem. Smart meters rely on constant data communication. So a lack of reliable connectivity is a substantial impediment in areas where cellular network coverage is sparse or limited. Because even in smart meters and all that, continuous connectivity is necessary. But since that is missing in villages, etc., so that problem is there. Third, the digital transformation of the power grid has made it a target of hackers. This we are all suffering because now everything is digital. And in the digital domain, I always tell everybody that, my dear, though it has got wonderful advantages, wonderful applications, we can do many things, but there are hackers and they make our life hell. The world's first successful attack of this kind happened in Ukraine in 2015, leaving thousands without power. So when you are using AI in power sector, where it is all digital transformation, so this type of problem may come. Successful cyber attacks on critical infrastructure can be as damaging as a natural disaster. It can be as damaging as natural disaster. The growing threat from hacking has become common and a matter of significant concern, particularly due to the fact that smart metering and automated control have come to represent close to 10% of the global grid investment, equivalent to 30 billion a year. Fourth, integrating different data sources and ensuring representatives given the diversity within the data will be challenging. Other challenges may also arise as a result of a low volume of data for machine learning models. We all know that machine learning will be successful only when the data is available in large number. If data is less, the performance of the machine learning may not be very accurate. Contextualization and transfer of learning of two similar tasks could prove to be difficult. Furthermore, these models could be susceptible to inaccurate data. These challenges are being partly addressed through reinforcement learning. Fifth, AI-based models are essentially black boxes. See, when these AI models are made, the normal user will not know the details of that. It is just like a black box, the majority of whom do not understand their inner working, nor how they were developed, which constitutes a security risk. So if you buy a AI system for your power system, you don't know how exactly what is there inside, how it has been designed, how the algorithms have been used, because you are not involved in the design. So this can be a security risk. And given that existing models are far from perfect, it is necessary to have safeguards in place when incorporating them into energy system when combined. So the AI system on one side and the power system on the other side, they have to be integrated in a proper way. Finally, similar to other sectors that are increasingly applying AI technology, the power sector will need to address challenges such as governance, transparency, security, safety, privacy, employment, and economic impacts. AI is certain to play an important role in reducing distribution losses in emerging markets and in helping with maintenance and reliability issues. AI will also help with integration of intermittent renewables into the grid and will give operational autonomy to distributed energy sources and microgrids. Given the fact that AI innovations is being driven primarily by the private sector, IFC could play an important role. Of course, regulations are required. So, my friend, with this I conclude my presentation. Though there were some hiccups, but anyway, I welcome the questions, madam.
Thank you so much, sir. I
Yeah.
hope that this insightful session would have enlightened the audience. The question that I received from the audience end and the participation end is, what are the challenges that are being faced by this AI in the electrical power system?
Yeah, in my last point, when I was dealing with the future of the power sector, and when particularly when you are using the AI, I have just now said that AI and particularly machine learning and so many things are there, and they will depend upon the data. You have to take care that whatever data you are supplying, they are correct and they are pure and they are good in numbers. Then only it will work. And second thing, I just now said that there are two parties here in the whole system. Number one is the people who are developing AI system, and second is your power system, right? Now, when you are incorporating AI into the power system, unfortunately, the experts or the engineers of the power system, they are not experts of AI. So whatever AI people, AI experts, AI engineers are giving you, it is like a black box. You have to rely on them. And that's why I mentioned there may be security threat. But normally it happens, even in a telecommunication also, we are all getting the black boxes and they are working satisfactorily in compression and other things. So we have to rely on them. But then these are the things when you are using artificial neural network or machine learning or fuzzy logic, well, they will work. Only that proper training is required. Yeah.
Okay. Thank you so much, sir. This was it. I would now like to request Professor M.N. Huda, sir, to please kindly present a certificate to Mr. R.K. Singh, sir, as a token of remembrance. Please, sir.
Thank you so much, Singh Saab, for having enlightened us about AI in power system. This certificate is not for the purpose of certification, rather a purpose of remembrance, as and when you see is part of this wonderful and lovely webinar after webinars. So thank you so much. We'll meet again for another topic.
Yeah, thank you, Dr. Hoda. The only thing is that again, we had some problem in playing. Otherwise, I
No.
had a wonderful
Oh yes, no
videos.
issue
And if
at all.
time is given, I can really explain it in a much better way.
Yes,
I
yes,
myself is not very much satisfied.
No, you did justice to the job. The topic itself is so vast that nothing can
Yes.
be done, and such kind of technical issues can come with anyone. But that's
Yeah.
not an issue, right?
So
Thank you so much. And this
thank you.
memento again is a part of remembrance.
Right, sir. Right, sir.
Thank you so much.
Thank you, sir. Thank you.
Thank you. Bye.
Thank you so much, sir, for giving us time. I also would like to thank our distinguished panelists and participants who have continuously supported us through the webinar. A big thank you for joining us on this auspicious day. Wish to see you in our next webinar. Thank you till then. Dear participants, we have shared a feedback form link on the chat window. Kindly find the link, fill up the feedback form, and also generate your certificate of participation by filling up that feedback form. Dear participants, you are requested to please enter the correct data as you require it in your certificate. I request all distinguished participants